Everyone. It's not a massive crowd today, but still, I think very interesting sessions we're going to cover today. That's the Brisbane Serverless Meetup, so I think you all seen the meetup page, otherwise you wouldn't be here. We used to run them in the Valley, so Mantel moved to this office, so that's going to be our new location, our new hub. For those who don't know, Mantel, it's a consultancy firm that works with many Australian large enterprise businesses. We cover domains across cloud, digital, cyber, delivery, so you name it. We're also partners of the year of AWS, Google, Databricks, and I think we're emerging partner of the year of Snowflake, so really broad set of expertise. If you're ever interested in working in consultancy, please reach out either to myself and I can connect you with our recruiters, or go to the mantelgroup.com.au. We've got quite a few vacancies right now. So, and Mantel provides obviously this venue, food, drinks, so thanks to our sponsors. We're trying to be cloud agnostic, so I don't really care too much if you like AWS more than GCP, so we're not AWS user group. You can be open, and I hope that Clara will be open about her experiences with both. Yeah, and tonight we have two great speakers. So Devang is a consultant from Mantel, and he's going to talk about quite a hot topic: large language models. Why do they hallucinate? If you use services from AWS like Amazon Bedrock, and Amazon Bedrock is a keyword here because it's a serverless managed service, so that's why he's here. Yeah, we're gonna discuss how to use Amazon Bedrock agents and how to detect those hallucinations early in the pipeline. And Clara is going to present her topic on how to migrate from, kind of convert from I think AWS to GCP land, and understand which services are equivalent or not. So as I said, it's fairly informal setting tonight. Sorry for the beer. It's actually, I just tried. It's not the best. We do have some soft drinks over there. Pizza is on the way, so we're going to have a short break between our presentations so we can have a bit of dinner together. Yeah, and if you have any questions, I think we're always going to have maybe 5-10 minutes at the end to have a bit of discussion. Also, feel free to share your experiences. As I said, it's fairly informal. All right, over to you, Devang.
Yeah, thanks. Okay, all good. Welcome to the session, and first of all, thank you for being here. All we all know it's pretty hard, and putting effort at the after work meeting, and so I really appreciate that you are in this session. What we are talking today, it's all about the hallucination, right? So we'll start from the RAG approach. So if you don't know about the RAG, we are going to fundamentally understand that concept of a RAG and how it's been connected with the large language model. And then after that, we'll look into the prime reason of the models, why they hallucinate, and what does it mean when we say hallucination, right? And once we find out the hallucination, we're going to use some evaluation framework. I prepared some screenshot of the examples where it basically checks the hallucination score, and then we basically use that into real-world chatbot system in order to detect that hallucination, right? So we'll start from the first and foremost, the meaning of hallucination. It's all like a human, right? Sometimes if someone asks you a question and if you don't know the answers, you say you don't know it, or you make your answers, right? Same thing goes with the large language model, right? So if I ask you how many moons that the planet Jupiter has, anyone?
67. No, maybe 90. No, 120 or something. It keeps going.
See?
It keeps going up. I'm hallucinating.
Yeah.
Because the data I'm recalling.
Okay.
Different time periods.
See.
Different truths.
Yeah. So this is a part of a reasoning. That's what it's doing.
We set that up earlier, but
right? So this was one of the examples of a hallucination, right? Even the answer is correct, we don't know the source, right? And why we need this? Because mainly if you go to the health industry or legal industry or any financial industry where the accuracy matters, we need to be assured that whatever the answers that is generated by these models is 100% accurate, right?
So that's a fundamental concept of hallucination. And we'll start from the reg, why we actually need reg, right? Why we can't just use LLM, right? We'll go through that. So before going to main part, I'll introduce myself. You can see some sweet logos there. But I've been working with Mantel as a senior consultant from last 2 years now, and my access card still doesn't work sometimes in the lift, so still figuring out. But over the years, I got a pretty good opportunity to working with these all extraordinary clients. The main highlight point is the center one, which is the QPS, where I worked on the billable generative application to find out the domestic violence cases, right? Another one was the Gold Coast Health Hospital, where we create a productionized system to create a discharge summary for clinicians, right? And in both industries, we need the accuracy. For example, that discharge summary report that we created for the doctors, that comes out from the clinical notes, right? So the day you enter in the hospital and the day you discharge, everything is tracked, everything is audited, right? So traditional approach, if you go to the uni, sorry, not a uni, but if you go to the hospital, you'll see those doctors are just using a manual writing approach when they create the summary. So it usually takes around 7 to 10 days for them to just create a summary and hand it over to the patient, right? We wanted to automate as an end-to-end flow. Obviously, there is a human in a loop before we confirm the summary part. And when I say summary, it's not just a paragraph of summary, it's a 3-page document that we need to create out of the clinical notes, and that has to be compliant with the right governing body as well, right? So that was one of the notable work which I was engaged, and that basically tailed me more into a generative AI part, where I was going through most of the stuff after 2018, right? Other than that, I also play badminton professionally. So if you are the person of shuttle or racket, reach out to me. I'm always keen to play. And after hours, I'm a lecturer at Victoria University. So I teach from cloud computing to cyber defense to project management to the master students. So that's pretty much enough about myself. Now let's start with the first topic and the key discussion area, right? So pretty easy. It will be very standard. That's my guarantee. I will not bore you. And if you just pay attention here, you'll at least learn one thing out of this session. So first is, obviously, we'll start from the fundamental of reg, why we need reg, what does it mean, and why that evolution started. Once we identify the reg understanding, then we'll go to the problem. So we need to understand how these different elements work, right? So we'll go through some examples for that. Once we identify those phases, we'll go to the hallucination. So identifying which part in that reg is a problem that creates that hallucination. So identify the problem, that's the first 3 parts. Then we'll go through the evolution framework where we track the problems and how we can create the scores. And last not least, but the bedrock agents that I'm going to use in order to create that into implementation, right? So it's fairly sequential areas, but I try to go as fast as possible. So first, retrieval augmented generation, right? So I'm sure everyone have used the ChatGPT when it was launched in 2022, right? Anyone remember what was the first model?
3.5, you mean?
3.5. Anyone else? Huh? So in 2020, OpenAI released GPT-3, all right, which only had 2048 tokens. So if you don't know tokens, token is basically the the textual information or prompt that you supply, it converts into a token. So pretty much roughly 1.5 words each one token, right? Now, when first time when you use the ChatGPT, you probably aware about every time you ask a question, sometimes you hit the limit, right? It says you are reaching the limit, you need to shorten your question, or you just need to get the short answers. Second thing, if you want to ask a question specifically for your data, for example, if you want to attach your PDF, your document, your Excel, and if you want to ask a question about that particular file, obviously there is a problem because it only can ingest the 2000 tokens, right? Now, there was two problems. One is a context window for the large language model. Second, that started after you had that bigger context window, which was finding the relevant answers. And that basically solves by reg, right? So retrieval augmented generations, that's how the abbreviation comes out from the reg. Let's understand the flows, right? So there are 5 parts here, very simple. I try to make that simple workflow as much as possible. So there are total 5 parts. As soon as the user asks the question, that's the first part. So here, user submits a prompt, that's us, right? Every time we submit a prompt, that goes to the tool, whatever for example, ChatGPT or using Entropy, whatever, right? That receives that, and before we start all other processes, let's understand there is 2 blocks there that you see there. It's your knowledge store, right? So that's your raw data is already uploaded to serve you some kind of a relevant answers, right? So that's your knowledge store. Now after
for knowledge doc, they are using KEG, as I remember.
KEG?
KEG, knowledge augmented generation.
Yes.
That's retrieval, and that's KEG is knowledge, KAG.
Yeah, but I think that's part of the. I think you're just saying the name of the process, but what we're using is just a database where you can upload your files and create a vectors and stuff like that. So I'll explain everything, and then we'll go from the from there if you have questions. So as soon as the user submits a question, it first goes to the knowledge store. That's the second part. Why we need to go there? So the question is asked now. Let me give a relevant data. That's what knowledge store is saying, right? Now the knowledge store will give you some kind of a chunks, right? So for example, if knowledge store has, I don't know, 50 files, but based on the question you ask, you already got, let's say, filtered out only 3 files. But the 3 files is big. You can't supply that everything to the model, right? So you need to create the chunks. So now, rather than supplying the document, there are 2 methods. We're going to learn the 2 methods as well. But let's assume those documents now converted into chunks. So each chunk is, let's say, 500 tokens, right? So for model, it's easy to understand, easy to embed it in the system, right? So now, after the process 3 starts, you have the relevant information that you got from that knowledge base, right? So until that stage, everything you have is just 3-4 chunks based on the question that you ask, right? Now that part goes to the model. So that's the last part is your LLM. That's your brain is. It says, okay, this is a question. This is what I found as a chunk. So question plus chunks that goes to the model, and that model only processes that 2 things, and then give you the answers back, right? So now this is just a fundamental concept of a reg, where there is a retrieval part, there is a generation part, and there is an integration part. So let's understand this. Again, going blank to the picture, but now we'll go to the phase. So the first phase, so this is the element of the phase where the knowledge store, knowledge base is there. It's basically pre-processed for you in order to give the answers that user is asking for. First part is a retrieval. So as soon as you ask the question, knowledge base retrieve, right? The retrieval retrieve the chunks, and that retriever goes to the generator to generate the answer. And the way it works, yep.
So usually retriever must be MCP server, as I understand.
Now MCP is a bit different. So where you have multiple agents, and if you want to combine those multiple agents, you basically put MCP server, which can handle the query between those agents. So let's say if one agent is just good at answering financial questions, you have that fintech agent. If you have some other agent is only good for the travel information, you can create multiple agents, but you can put MCP integration, MCP servers on top of that. That is enough smart to route the query based on the question you're asking. So that's the MCP part. It's a model context protocol, right? Now coming back to the, and it is completely different than reg. And the last phase that you have is integration. So integration is important because you want to augment that. You want to get the chunks from the retriever, give it to a generation, So that's why we need that integration, right? Now what's the problem, right? Why we need hallucination? If everything is just rose and petals, where is the problem? Anyone else? Where is the problem? Which phase is a problem?
I think last this
Generator?
LLM is the problem.
LLM, okay. Anyone else?
No, you might have crap data in the knowledge base.
Yeah. You might not have chunks that appropriately match the query that
Yeah.
you're sending.
So that's basically the winning answer. I would go for that. Okay, so let's look at the retrieval part, right? So there is a thing called pre-chunking and post-chunking, right? So it's all depend on what's your requirement and what you want to go for. It's the same like when you want to choose a cloud, you go through the whole phase of a discovery with the requirements and then you choose a cloud. Same thing applies here, where as soon as the user asks the query, it converts your query or text information into a vector. So if you don't know vector is just a numerical representation of your words that's stored into 3-dimensional world, right? So now embedded model creates the vector of that and store into a vector database, right? So that's the first part. Second part, it's already pre-done before you ask the question is your documents that you want to submit, right? So rather than putting whole your document and create embedding, you dividing that into a chunks, right? That chunks creates into the embedding, which is vector, and then stores into vector database. So until this point, you have your chunks ready. Now that retrieval chunks from here combines with the prompt template. So prompt template is another way of, telling model what you should generate, what you shouldn't generate, right? And what output you want to get when you see your answers. So that's additional. It's a one extra layer if you want to get the answers that you already anticipated for, right? Now, then large language model takes that chunks and query and give you outputs. The important part for this process is why it's pre-chunking, because you see the documents creates the chunk first before it hits the embedding. And in the second part, it whole document converts into the vector. And then whenever you ask the question, based on your question that you ask, it basically finds the relevant chunks from that vector space and then give you the chunks out of that. Right? This is the smartest way of using chunking, because this is more faster, right? So now you don't need to worry about how many chunks you want to create. Do you want to create 500? Do you want to create 1,000? 700? You can just supply your whole document, because embedding models are smart. They create vectors, stores that whenever user asks a question about the relevant thing. If it finds that, it will give you the relevant chunks for your template. And obviously you have a prompt template before it generates the answers, which will 90% handle the quality that you want, right? But until here, you still have hallucination. What we are learning is just the retrieval phase, right? How it creates a chunk. Is it pre or post? Now, other than that, because now this GenAI is coming into all different parts of the field and the work we do on day-to-day basis, we have different chunking methods, not just pre and post. Right? So there's total 10, but I'll only go through the most common that we use in the market. First one is fix. So fix is nothing. You just say, okay, chunk size 500, and it will create each and every chunk on 500 tokens, right? Second is semantic. Semantic is more like a coherence. For let's say you have a case study, right? Obviously you have some statements which relates to other paragraph, right? So that relation is a semantic relation. So every time, even you find the answer at your 6th page, but if you have that one statement that connects to a 2nd page paragraph, it has to be related when it answers the question. It should consider that context when it should generate the answers. So that's part of a semantic. The popular one, that's what coming after RAG, it's called agentic search, right? Where an agent is smart enough to decide whether they want to create chunks or not. One of the good example is your cloud code, right? It doesn't do chunking, it basically search. So rather than chunking, for example, if I'm using cloud code, it just use a grep, glob, regex to search the file, rather than getting the file stored and create chunks, and if you want to use, you can use it for your questions. Now it's just searching whenever it needs to be, so it's more dynamic, right? The next one is the late one, which is exactly the same as a post chunking, where rather than doing a first, it just wait for the question to ask, and based on the question that you ask, it creates a chunk out of that. And then code one, very simple, it creates a code block based on the language that you're using for the generation.
But I have seen that this code method also called semantic chunking for code.
Yes, that's right. So you can obviously use hybrid. I mean, it's everything, because this whole industry, the reason it's evolving daily, because this industry and the field, it comes from the research background, and research never stops, right? In our cloud industry, we still have a research, but the scale and the pace that we use, it's quite different than the AI, right? And that's why we are seeing this evolution, and innovation is happening every day, right? So what I used to do when I started my first project at the Gold Coast Health Hospital, the solution that we delivered there and the process and tools that we use, it's not applied for today, because everything is different story. Right, so you need to be aware on day-to-day basis what's coming now, right?
And can you advise us some tools that can do this semantic code chunking for?
So Llama Index is there, if you're aware about Llama Index.
No.
Then LangChain allows some libraries which allows you to create those code chunkings. Right, so there are few, but again, it all depends on what you want to do, right? And it's all trial and experiment. You need to just, you will not achieve the result that you want in one go. You just need to try, repeat that and see what's working, and then you apply the knowledge to the next attempt, right? And then you improve from there. Right? It's all like a reinforced learning. Like if you're a kid, right, the kid starts crawling first. Then sometimes when it, when it tries to crawl, and it can fall as well. Right, but you teach them, right? You teach them how to crawl, then it start to walk, and then it can run. Right, you can't directly tell the kid to run. Right, so this is the same thing. It applies the same some practices and understanding. Okay, let's talk about generator. Right, so retriever, we already seen the chunking part, how it creates chunking, how this thing works. What about generator? Right, so we all know the chunking is a problem, because if generator doesn't get the proper chunks, the quality chunks, and the question that you're asking, the relevant chunks, you'll not get answers. You obviously have the same expression of this picture when you receive it, right? So problem is retriever. Now let's try to break it and understand and put into a practice where we can use it into a real practice. It's a very simple flow, but now all the services, it's all replaced by AWS services, right? So the bottom part that you see, the second half, is all your retrievers, right? So as soon as you ask the question, it goes to the agent, Bedrock agent. A Bedrock agent first looks that to the knowledge base where you have the user guide. This user guide, it acts as a formal ground source, right? So for example, if let's say an employee starts in your company, you first share the onboarding guide, right? So for that person, that onboarding guide is a sole ground truth reference to follow, that what you should do, what you shouldn't do, right? So the question that you're asking, you have that file created well before based on the examples that stores in your knowledge base, but it also has the historical data about your company, about what you're going to ask, right? So you still have a support from your background data, but your main file is here, right? So based on that, whatever the chunks that you get as a qualitative chunks, it's retrieved at number 5, but still your user will not receive the answers because we want to check the hallucination, right? That's where the second phase starts. Now you got your chunks here. In these chunks, obviously there is a query, which is a prompt, plus relevant chunks from this part retriever. It goes to this guy called hallucination detection API, right? Now that's one of the reason we are using agent, not a guardrails or a prompt flows in Amazon, because agent is fairly dynamic, right? If you want to just, for example, for this flow, if you want to change your hallucination logic, you only change the Lambda function. You don't need to, touch your rest of the flow. But if you're using a guardrail or Bedrock guardrails or any other, Bedrock prompt flows, if you want to change anything, it changes whole flows for you, right? So it's more static. This is more dynamic. Now, hallucination detection API, it's basically action group for the agent that based on the question that is asked, what are those 5 steps you want to take action on, right? So it creates a plan that first go and look for and trigger that Lambda function. And second, if hallucination is detected, call the SNS notification to get your human notified. Third is if there is no hallucination detected, get your response back to the user. So it has that action plan which is already been written from a user, obviously from a developer who is creating this, and that it's basically agent is smart enough to traverse through that action group, right? Logic remains in the Lambda function where you're using another LLM which is basically creating a reg score. So everyone knows reg score. What is a reg score? So whenever we are talking about the evaluation framework where we want to check LLM's performance, we calculate the score, right? So when these things started, we used to calculate a BERT score, we used to calculate F1 precision scores, we used to calculate RUG score. So each score is basically gives you a different metrics, right? What we're using here in this flow, it's called reg score. This is mainly built for reg performance checking, right? So I'll show you what reg score means, because the reg score applies to both phases of reg, right? So we'll start from the generation. So it check the faithfulness, means check how much factual information it's generating based on your prompt, right? So it checks the fact, whatever you are generating, is it factful or not. Answer relevancy, how much it's relevant that whatever you ask and whatever it's replied to. And in the retrieval part, first it checks the precision of the retrieved chunks and how much the precision that whatever you ask for. And last one, it checks the overall relevancy, not just to your prompt, not just the answers, but prompt, answers and chunks, right? So and you average out those 4 things, that what your reg score is, right? So rather than calculating each individual score for specific thing, now you just need to calculate one score which combines those 4 things that you want to check a performance on or check a quality upon. Okay, let's understand this example, which is the last part of the session. So we asked the question of what models are supported by Bedrock agents, right? That question go to the agent where it has the the main file that it should get answer from, but it still use your old your data that you already provided and give you the provided relevant chunks. So this is a retriever part. The answers that it generates after this 4th stage is this. So it's saying Amazon Bedrock supports foundation models and it gives the different models, probably you are aware, right? Now rather than sending this answer to the users, we have action group. If you remember the first flow that we see, this action group, what it does, takes this question, takes these answers and go to that detector, the hallucination detector, which is a Lambda function, right? And based on the logic that we have, we'll get a score. So if you see the right hand side, we got a score of 0.4. Right? Now that 0.4 score is obviously less than what we expect. So if we expect 0.9 and 0.4 is less than 0.9, obviously, so there is a hallucination. Right? Because the question now, the answer you see, it's only for Bedrock service. We ask for Bedrock agent, not the service. Right? If you see the question here, we said what models are they supported by agents, and the answer it gave what Amazon Bedrock supports. Right? So now based on that calculated score, it will put a human in the loop and say, please wait, someone will support you, rather than giving this half wrong answers. Right? So this is just an example. You can play around with the different stuff, and that's what makes this very powerful if you want to use it. Yes?
I still cannot understand. Where's the logic? So model answers to this question
Yes.
one thing,
Yeah.
and the same model tells, oh, that's the shit.
No.
How it detects that this is not coincide with the question?
Okay.
If that was generated, but by the same clever model.
Okay, so first of all, I agree, but the second part I don't agree, because it's not the same model. It's called LLM Evolution Regs Framework. That's what we're using.
But how that another model can understand whether this answer is accurate to that question without all this data that was provided to the original model?
Because that model is only expert on checking evolution. Does it make sense?
No.
So, so this
mod-
LLM,
These additional data was provided to that. Where is the model? Okay, to
let's
that.
say here, yeah.
To that generating this response.
Yeah.
And now only this question and this response is provided here, without all this additional data. Why this question was answered that way? How this model can detect quality of that answer without all this
Because,
additional data?
yeah, so the lambda function, the logic, so when we generate these, we are not using the same model for both. First of all,
Okay.
let's clear that, right?
Okay.
That's a different model. That model is expert on just checking the evolution. So when we say evolution, we are just looking at performance of LLM, right? So if I Google it, so let me just go out of topic. So if I just say
We
LLM,
can provide simple, maybe example for us developers. System develops the code,
yeah,
and now you say this model, you call it evaluation model.
Yeah.
Okay, will understand the code and will tell whether it's good code or not for that particular prompt.
yeah, I can't say for the prompt, I can't say the code, but if it's relevant information on text, obviously it is, because it's
That's not how it will understand is this code relevant to that prompt.
yes.
If this was generated by huge GPT-5 model,
Yeah,
and the
but it's not the
shift
same
was
model
done
again.
by smaller.
Yeah, so that's why it's powerful, right? So because it's not the same model, right? The GPT-5, when you say it's trained on the different data than what we use in the embedding part.
Okay, and what's this embedding model?
It's the same model. So for example, let's say Claude, right? So Claude
Okay.
3.5, let's say Sonnet or whatever. You can use that model to generate your answer. But when we talk about embeddings, which is giving you the prompt, the chunking and those things, it's a different model, but the name remains the same. It's just the embedding that ends. So I'll show you that's what I was saying.
Understand. So embedding model can understand that this code is not relevant to the prompt, but ChatGPT have generated that irrelevant snippet of code.
Yes. So because the question that you're asking, it's not trained on LLM, right? So that knowledge is not already present for the model, right? So what we are doing, we are adding layers, right? One layer is your prompt template, another layer is those knowledge stores, so we are giving as much as information which is relevant to your question that you're asking, right? But models still hallucinate, we all know that, right? So we are adding one more layer that can be, get another model and check that what that model is giving you a score, and based on that score, if it's fit within our logic, we'll reply back to the the user. Otherwise, we'll say, okay, just wait, someone will confirm.
That's clear.
Yeah.
Still not clear at all how that model, much clever than ChatGPT that generates.
Okay,
the answer.
I'll give you the basic answer. If you search for LLM evaluation RAG framework, RAG is framework.
Evaluation.
Yeah, and we can go into that. And I'm more than happy. Yeah, go ahead.
I was just going another possible hypothetical question: when lawyers get caught citing fake cases,
Yeah.
obviously the ChatGPT has provided them a case that doesn't exist.
Yeah.
And would this layer be functionally double checking that the cases that are referenced actually do exist?
Yes, that's right.
So, but that doesn't get to the back end
Yeah.
question he's asking.
I think what he's asking is more about the logic, right? And that's what is.
That's the logic, but as far as I know and what my friends suggested,
Yeah.
I'm now looking for a job and I'm creating cover letters
Yeah.
and resume for a particular position. I'm given position, my CV, and say, please adopt it.
Yeah.
And what it does, it lies. It tells that I know everything that is in position.
Yeah.
And your last part, this evaluation of
The framework.
Lambda function,
Yeah.
will check this, but what my friend says, just tell to ChatGPT additional 2 words, don't lie.
Yeah. But for that particular example, sometimes it works. This framework only fits where you require higher amount of accuracy. For example, if I'm applying to the health problem, right, I'm not expecting 0.2 milligram to 0.6 milligram, otherwise patient will die, right? So when you have that level of accuracy,
I will ask
only then
the
you do
model
this.
Give me more precise answer
Yeah.
at the beginning, not at the end.
So you can do it.
The answer.
Definitely
Maybe
you can.
it will generate proper answer and
Yeah.
that's it. I don't need that loop.
Yeah, you can definitely do that, but that's a one way. You can't do that. The
But
similar.
it's quicker way, I mean,
But-
to give better prompt to get better results
100
rather than checking results.
100%, right? As I said again, this framework only applies when you require higher level of accuracy, right? For you, for example, you're just asking the questions, right? Let's say the example which I gave about.
For me to understand, if I will get the response from ChatGPT
Yeah.
and will take this response
Yeah,
to Claude and say, Claude, please check, is that correct?
yeah.
And that's the same what this system is doing.
No,
is it right
No,
or
it's
not?
different. It's a different.
Okay.
I'll explain later
I cannot
because we are
understand
running
what this elevation
Framework.
system is doing.
Yes, I just worry that we got pizza that is kind of cooling down.
Yeah, we'll take a break, but I'll definitely explain you. I'll clear you.
Cannot get what this system is doing.
But that's why I'm here. I'm trying to teach you.
Maybe I'm the only one who don't understand.
I don't know, but I'll try to.
I
try to-
think this is great questions. I think a lot of those questions we also have in our minds, and
Yeah.
we're probably just a bit sometimes embarrassed to ask.
Yeah, maybe that's.
I think the context here is you're demonstrating it within a framework. It's specifically for a hospital, so it's already got
Yes.
some guardrails within there, and so both models are kind of within some containers.
Some containers.
You're describing it within
Holistic,
everything
yeah,
is
holistic,
correct.
yeah.
That's too broader a correction. So that means, I
Yeah.
think it's not. Your question is correct, but it needs to be contained to say if I am in a specific situation, like in this case, you're using the example of the hospital. Both models would have been trained within
Just
the
for
context
that
of
context,
understanding,
yeah.
Is this model correct within context of answering this medical question?
Yes.
That's what it is.
Yeah.
It's not general to answer all of it because that's too huge.
Yeah. We are talking about the business,
Yes.
based questions and use cases. We're not talking about, like holistic general thing like create email or write email for me,
So
right?
would it be
And
fair to
in
say
that case,
the
that's what you use.
To answer this little subtle question, the user doesn't have to be so sophisticated to use the model versus.
Yeah, holistic framework. Yeah,
Right?
yeah.
Maybe
Makes
that's
sense.
the benefit of it.
Yeah,
That's, yeah, but for that, yeah, you are totally right. And in this case, I want to mention about this recent Samsung's model, a tiny recursive model that can recursively check themselves. That's my question. Is it the same or not?
No, it's not same. So
Because
obviously,
recursive model-
if I'd be the you, and if I want to create my CV, I'll just say, I'll create my prompt that sophisticated and get answers. I'll not do this, right? But when I'm doing this for client, where they don't want that a single element to get as a made up answer, I need to be accurate and see and divide those granularity, divide that each and every part into different step where I can manage that individually, right? I can definitely answer your question individually, but I think we are running over time.
Cool conversation. Let's take it off for a break and
Yeah.
continue on.
That's pretty much it.
Oh,
Nice.
Wasn't it a good presentation?
Yeah.
Yeah, thank you.
I mean, interesting. Possibly an example, like a simple query example where there was a hallucination and then an example of how this system would catch that hallucination might make these hypothetical concepts a bit more concrete
Yes.
for people to
Yeah.
understand.
I was thinking to run a demo but it's a very tight timeline, so probably half an hour. Right.
but on the other hand, also keep in mind that the model's evolving all the time.
Yeah.
The internal reasoning is now taking a lot of kind of similar logic that we had to
Yeah.
implement.
Now more sophisticated engineers not using RAG, they're just using agent,
Yeah.
right? Which are now more
And if you've
sophisticated.
been using like agentic coding, if you've been using tools like Cloud Code or anything like that, like previously you had to split your steps into like plan, analyze, and now it's all doing it for you, right? Because it's kind of mapping out the plan.
Yeah.
Which is actually quite exciting, but I think it's really good to understand what's going on behind the scenes. As
Yeah,
well, right?
yeah,
So you can, yeah, that's really good.
That's it.
Well,
No,
are there
it's-
any
thank
questions? We've got a pizza, and yeah, let's have a bit of break, and then we can grill Clara.
That was a hot question.
I'm going to try to do 3 cards out. Cool. Hi, everyone. My name is Clara. I'm a software engineer at Convert. It's an agency, and we make e-com website. And what I'm going to share with you tonight is basically my struggle as a developer to move from one cloud provider to another while building application. There's no comparison between the 2 cloud providers, literally me trying to provision with another provider. So if I say something inaccurate, feel free to correct me because it's a learning curve. Before we get right into it, a bit about me. Those are the countries I've lived in. I'm originally from Italy. I spent a couple of years in France. I moved to the UK for like 15 years, and I made it to Australia last year. I decided it was time to move to the Southern Hemisphere and get confused with the season and calendar. This is my first encounter with programming languages. So, yes, Pascal.
Turbo Pascal or
Yes.
Turbo?
Bonus point over there. That was before the mouse was invented, just so you know.
I'd forgotten
Like a
that.
square.
Yeah, just keyboard.
I'd forgotten Turbo Pascal was a thing. Give me flashbacks.
Fair enough, you did have variables and for loops and if statements, so you know, became useful later.
I remember I've heard of it.
Because that was the Stone Age, computer science wasn't a thing, so I went off to university and studied economics. So I kind of did a detour, I went into marketing, and then I made my way back into technology. My company was going through digital transformation, so from monolith into the cloud, serverless, microservices. This is how I got familiar with the technology and the new world. And then I was having so much fun with my engineer as a product manager that I decided to do a career change and became one. So now I just build things and use that gift more often. Cool. So when I started, version 1.0 of Clara was AWS cloud provider. I joined a team that was already established, and the services we were building serverless application, and the services we used the most were Lambda for computing, Event Bridge is my favorite service for event-driven architecture, step function for orchestrating application, and then it doesn't really belong there, but for networking, API gateway. Security, we use Cognito and IAM, and then secret manager, all this jazz. Monitoring was CloudWatch, and then for storage, S3 bucket. And my infra as code tool was CDK, which stands for Cloud Development Kit. It's the best thing in the world because you can use your programming language of choice to provision. So I studied TypeScript, so I use TypeScript, and then CDK behind the scene transform your TypeScript file into CloudFormation so you can get provision. CDK handles concurrent deployments by putting your stack into in progress state. So if you work in a team and several people are trying to deploy at the same time, which is going to create chaos, it will prevent that by kind of blocking your stack. And then if for whatever reason you do something dumb in your stack and your deployment fails, CDK rolls back everything. So whatever was deployed up to that point get erased and your stack goes back to before, like nothing happened. I joined a project that was already set up, but if you start from scratch, the only thing you have to run is actually CDK Bootstrap. And there's magic. It creates a bucket. I don't know what it does, to be honest, but it's all you need. After that command, you're off to go, you can deploy. And then one of my favorite things about CDK, and we'll find out later why, is that if you have a Lambda and you want to update your source code, like you do sometimes in your application, CDK does it for you. So you go from your starting code from here. This is TypeScript. If you go in the console, you will find your source code in your Lambda page in JavaScript, which gets compiled. And let's say you want to make sure your application works, so you add console log. This works. You go off and deploy, and then you go back in your Lambda, and you will see that your code has been updated. So if you want to update either your stack with your sources or your source code for your Lambda, you do exactly the same thing. You go off and CDK deploy. And here you go. That was my life, and then I changed job, and I had to upgrade myself to a new cloud provider, which is Google Cloud. So the first thing I did, I knew nothing about it. I was like, okay, let me try and map the AWS services with the GCP services, so at least I know what's going on. Computing, they use Cloud Run, kind of a trap, really, because Cloud Run is split in two, Cloud Function and Cloud Run. Cloud Function, that was last year, now they also call Cloud Run Function. If you search both of them, the console will actually give you the same list. The Cloud Function, you point to a file, and Cloud Run needs a Docker file, but they're both like serverless. Then application integration, you have PubSub for event as an event tool, workflow for application orchestration, and then API gateway, called the same in both. Security, they have IAM, again called the same. Secret manager, I believe that is. I don't think they have anything like Cognito. I did Google what's GCP Cognito and didn't come up with anything. And for monitoring, they have called Cloud Monitor, but then you go into Cloud Logs. It's kind of the same. And then storage, this is just called bucket. This is WSA3. It's a bucket, and it does what it says. Once upgrading myself to a new cloud provider, I also have to upgrade myself to a new infra as code tool, because GCP has to be provisioned with Terraform, which is fine. Terraform has its own syntax. It's not as scary as it sounds. They have very good docs, actually. You can literally copy and paste and then change the name. You kind of like wrap your head around like module and how to pass the var around, but it's okay. There was another learning curve though with Terraform. So Terraform, obviously being a deployment tool, detects your what needs to be updated, create or delete in your stack. How does it do that? Hazy. Welcome to the state file. If you ever work with Terraform, that's probably what gave you grief. It gave me a lot of grief. So the state file is a snapshot of your stack at that point in time. So what Terraform does when you deploy, generate a state file. So next time you want to deploy, it's going to check what you have in your provisioning file, what's in the state file, compare, and then decide, oh, this is updating, this is deleting, this is new to be created. The state file is a file, so it has to be somewhere. So if you deploy from your machine, Terraform just saves it and sticks it in your machine. If If you work in a team, no good. If your deployment is done by a CI/CD tool like GitHub, not good either. So what you need to do is find a place where everybody can access the file, which is some sort of storage. And luckily, Terraform is integrated with all the main cloud providers, so you have to create a bucket and stick in a bucket in GCP bucket. And then you gotta tell Terraform where to find the state file, which is this little backend block, and tells it a Google Cloud bucket, this bucket in this folder. And everybody can access it from here, and when it gets updated, it gets stored there. So Terraform can sort itself out. If you make the mistake to have it on your machine and deploy in the real cloud, you gotta migrate it from your machine into the bucket. Not fun, so do that upfront. Once you have this in place, it's all good. Terraform manages the concurrent deployment by locking state file, kind of acquire locks, I think is the wording. But basically, if somebody else trying to play at the same time, they go, sorry, can acquire state lock, pipeline fail, wait your turn. The mid-deployment failure is slightly different. It means that whatever got deployed to the point of failure stays deployed. Your state file gets updated accordingly, so it's not the end of the world, because next time you redeploy, you will know what is being done or not. But if you're like me and your pipeline fails, and then you think, oh, nothing worked, then you go in the console and you find out that your pubs have got provision, you start getting confused, it's like, what's happening? What have I done? What is that state file going to do to me? It's fine. State file knows better, so you're good. Cool. So let's go into services. As I said before, I did try this mapping to kind of know what's going on. That's good if you want to know what's going on and trying to do solution design so you know what services are available. Don't get too caught up in the fact, as I always say, AWS works. I'm expecting to be the same, because it's not. I'm telling you. IAM, if you're not familiar, I think stands for Identity Access Manager. Is what you use to give permission to your resources to talk to each other. In AWS, works like this. You create a role, and then you create a policy. Your policy has an action that would be, I don't know, write to Dynamo database, and then it has a resource. So your action is tied to that specific resource. You attach your policy to your role, and your role to your resource. The way it looks in the code, this is AWS Rush and all, if you're not familiar with them. To create a policy, you need to create a policy document, which has a policy statement, but once you're done all the level, you create all your permission, and then you attach to the role. Some of the resources in AWS get provisioned with a default role. So you don't have to create a specific one. Your Lambda will have a default role. So the only thing you want to do when you need to keep more permission is just create the policy and then attach it to the default Lambda role. And this was my understanding. Then I moved to GCP. They kind of use the same words, but they don't mean the same. So in the docs, it would be like, oh, you need to grant role to your resource. So you're sitting there like, I got that. Gonna try and provision a role. There's no role. There's no resource called role. Then you panic, and then you find something called IAM member, but it's very confusing. And you go around in a circle, and then you land it on, I gotta create something called service account. That's basically your role. And then you create something called IAM member. It's the name of the resource, literally, you provision, which has a role, which is the list of the default role, like Cloud Function Invoker. And then you got a member, which is actually your service account. And then you type your service account to your resource. None of the resources that want to use get provisioned with a service account automatically. So you always have to provision one separately. And you just declare it like this. You go, okay, give me a service account with this ID. All service accounts have an email for a reason unknown to me, but GCP handles it for you. So you put your ID, and then it will automatically add this dummy at imgserviceaccount.com. And this is how it kind of works. You provision your service account, and then you provision this IAM member, where you say, that's the role I want to this service account. If you have multiple permission, you have to provision multiple IAM member, and then you're just gonna go and add it to your resource. You say, that's my service account. Now, at this point, I'm sitting there thinking, this thing here is, I don't know, workflow invoker permission. But what about the least privilege principle? This is like free for all. So kind of like, surely this is wrong. It's a bit of a mixed bag here, because when you give permission to a resource to talk to another resource, the receiving resource actually has to allow you to talk to them. So this resource restriction is done in both. So your workflow will say, oh yeah, I can be invoked by this service account. So this is how you restrict this privilege. Now a bit of a warning, I did break the GCP project for everyone. There's two other resources under IAM called IAM policy. That was a trap. Because from AWS, you go like, oh, policy, this is what I need. No, this is like the project level, and I think you give specific permission to a bunch of users, but if you're not careful, you're gonna lock yourself out of your project, so don't do that. I think I tried that, and I broke access for everyone. DevOps OER for me. And the IAM binding, I still don't know what it is, but I didn't have to use it, so if you know better, let me know later. Cloud Run. This is like, oh, this is easy, I can do it. This is how you provision a Lambda. You literally put your entry path, which can be your TypeScript file. You give it an ID, and off you go. You can add more settings, but that's the basic. 4 lines of code. And you go in the GCP documentation, how do I provision a Cloud Run? Cloud function, Cloud Run function. A list of resources starting with a storage bucket. You'd be like, I don't think I need to do that. You return the docs like 3 times, and then you get it. So what you need to do before you even get to the cloud function provisioning is save the source code of your application. This is why you need a bucket. If you join a project that's already established, they're likely to have a bucket already. If you start from scratch, you need to create a bucket. Then you're gonna zip your source code, which has to be, if using TypeScript, is a JavaScript compiled version. And then you save it in a bucket. So you create a bucket object. And once you have your source code stored, you can finally provision your cloud function, and then here, you point the source code of this cloud function is in this bucket, this object name. Then there was this thing in the doc, here. And I'm like, I am member, don't know what it is, it says Cloud Run, I'm provisioning a cloud function, what you're on about, ignore. It became useful later. Because once I managed to provision my cloud function, after my Terraform log file and everything, I had to invoke it with an HTTP call. So in AWS, what you normally do for that, you provision an API gateway, you create a route, and you point your route to your Lambda. Here, much easier. The cloud function actually get provisioned with an HTTP URL already. So the only thing you have to do, it's in the config of the cloud function itself, allow the traffic, and it could be all, or it can be internal only, and I'm sure the third option will remember. But if you want to have a public one, this is when your IAM role becomes useful. And here, for some reason, you see it's a specific Cloud Run IAM member, so you can type to your Cloud Run. But you're basically saying, I want all users in the world to be able to invoke me. And this is how you make it public. So that was my cloud function sorted. And the other one I had to do was being triggered by an event, which in the modern architecture, like event-driven is quite common. So I'm like, how do I do that? That was also easy. What you have to do is in the cloud function itself, you provision an event trigger. Sorry, you add an event trigger block in your provisioning resource thing. And here you say, I want this to be triggered by the message published on this pub sub topic. And because we just said before, sometimes the permission kind of goes both ways. In the same cloud function, you're going to say, yes, but only this pub sub service account can invoke me, not all pub sub account. And this is how you time the permission. Now, I provision my cloud function, and then I have to go and update my source code because I got new requirement. You got a question?
Just
No.
had a small question.
No.
Because there was so much code, and when I used GCP, it was so much simpler where I would just go to the UI and then deploy a cloud function. Just click on
This is bad, man. Bad. So, yes.
Yeah,
you
I'm
can,
just trying to understand the use case of.
yeah, so you can obviously provision straight from the console
Yeah.
or
Not
even
easy.
from the CLI.
From
But
the-
normally, you want to create like a Terraform file, like an inference code, so you can deploy in different environment and be consistent. So
Yeah.
if I make this in dev, and then I'm just going to deploy in another project, which is my production project,
Yeah.
I'm sure that whatever I have in dev get replicated exactly in the same way in and then you can keep track of the changes. So if you break something, because you go here and delete an IAM member,
Oh yeah, I see.
you can see, and then you know, oh, we broke that, let's not deploy to production. But if people are poking around in the console, it's a bit difficult to keep track.
Yeah.
I'm not familiar with this type of stuff, but are SQL changes or database changes included in Terraform file, or it's a separate thing to prepare environment?
The way we've done it, we provisioned the MySQL in GCP, but then we had a typeform set up in the code.
So it's separately, let's say.
Yeah. But there was no my area of expertise. So if somebody knows better, feel free to intervene.
Just, I think there is Lambda URL available in AWS now as well.
Oh.
That's kind of whatever comes by default as your HTTP endpoint, so you don't need API gateway anymore.
That's good. See, this is what happens when you don't work with AWS for 2 years. You miss out the good things. Yeah, good to know. Because yeah, this is what Cloud Function does. You just get URL for free, basically. This sent me around for like a day and a half, I swear. So you want to update your Cloud Function code. So what did Clara do? Change, commit, deploy. Go and test, nothing changed. Like, okay, I've done something done, fine, go redeploy, still not working. So I go around to my colleague and I was like, oh yeah, because Terraform doesn't know when your source code changed. I'm like, excuse me? I'm like, oh yeah, we made a bash script. I'm like, what? No. It's like, I cannot believe Terraform cannot handle that. Like, surely everybody has this problem. You can handle it in Terraform. So the reason why your source code doesn't change is because Terraform, with the state file, look at your Cloud Function, and you look at your source code object. And if the object doesn't change, Terraform doesn't care what's inside the object. You're pointing at the same place, so it's the same object. So like, same object, not doing anything, off you go. So you gotta trick Terraform into know that your code actually changed, so you can use this. Terraform has a built-in function for hashing MD5. So what you do, you zip your file, and then when you store your object, in your file name, you append the MD5 hash to the name. So next time, if your source code changes, when you zip it, the hash will also change. And then the object name will be different, so Terraform will know, oh, the source code changed, go and fetch the new one, and off you go. I swear they're enough. But we made it. PubSub. So if you want to send event left, right, and center, you got to provision a topic. Very easy, just give it a name, and that's your, I'm going to say bus, but topic. And then if you want to listen to event, you need subscription. There's two types. Pull, your application pull the messages. Push, the PubSub push it to you. And they can be provisioned as their own individual resources. But if you have a Cloud Function, you don't need to. You just put the event trigger block as we see. And this behind the scene create a push subscription for you. So when you go to the console, you see it. And why do I know that? Because I'm sitting there thinking, okay, I'm listening to a topic, but I don't want all the bloody messages. I want this. In AWS, you can select the messages you're going to listen to. So you create a rule, slightly different way of doing it, but you can say, I want these specific messages with this field, with this value. So if I'm listening to all order created, maybe I just want to know about order created in this country or a specific transaction code. Don't give me all of it. Remove the noise. And on top of it, what you can do is also transform before the event reaches you. So you could say, okay, you're going to get an event with an alarm name. Don't send me an alarm name. Send me a message that says this alarm has been triggered. Your application is on fire. So I go around and find, okay, I need a subscription, but where do I put the filter? Where do I do this? Is a pull, is a push? You can't. Unfortunately, we haven't found a way to filter out the noise. You have to listen to all messages, and then your application can disregard what is irrelevant, basically. Once you are on the PubSub event going left, right, and center, the other thing you might want to invoke is workflow, which is the orchestration tool. Quick reminder, in AWS, the way you do it, you still create a rule. Instead of putting a Lambda as a target, you just say, it's a state machine, it's this state machine. Off you go. Nothing different. And now I know better. So in GCP, I think, oh, probably in my workflow, there's a way where I can put a trigger. No, kinda, but you need a little So your topic is going to go into an event arc, it's going to go to workflow. Don't know why. From the docs, straight from docs, so all good. This is how you provision it. So you start with your service account, then you give both permission, the event arc is in the middle, so you have to be receiving of the event and then send them off. And then when you provision it, you need to select an event arc trigger, because event arc is a service, there's several of them, so that's a trigger, where you say trigger when a message is published in this specific topic, and then send it off to this workflow, which if you provision in the same Terraform, you can just reference the ID, otherwise you just put the name, I believe. And don't forget to give the permission correctly. So once you say, oh, now I can invoke workflow. Yes?
Are these Terraform scripts all in one file or separate files?
You can do whatever. So you have a main file in Terraform.
And I can import from another.
Yeah. So you can have all your stack in one file, or you can create module. So you can reuse. And then yes, you can provision everything in a stack, or you can import. So there's actually I think it's a data, instead of using resource, you say data, and then you can import an existing and then reference it. Workflow. This is like literally chaos. Doesn't matter which way you look at it, it's chaos. The workflow is a step function, is an orchestration tool. So you got an entry point, and then you got steps. You want your app to do things, but then you start putting if statement. So if step 3 goes A, you go left. If it goes B, you go right. So you're gonna have branches and all a mess. There's no clean way to do it in CDK. Being a language, you can put your step in a variable, chain them, create branches, reference branches, just have an entry point, and then hopefully all the chaining will work. It's like organized chaos, but still not pretty. So you're moving to GCP, and you're like, oh, it's a trap as well. So the source code for a workflow, it's either a JSON or a YAML file. If you look in the console, the source is a YAML file, and you can see the steps. They're kind of all in order, so you think, oh, that's easy to follow. Yeah, until you start putting if statement and loops, and then it's not clean anymore as well. This is YAML, so it's very, very sensitive about your indentation, your spaces, your comma, God knows. I swear in CDK you get away when you use a formatter and he adds your missing stuff. Here your pipeline will fail because you have an extra space, and you cannot parse. This is like, oh, I'm expecting a column, there's nothing. What are you doing? This should be in this line. There's no dash. It's very, very sensitive. I use a little trick there, end up going in my own cloud and write all of this and trying to deploy to get around all the syntax issue, and then copy and paste in Terraform. So when you provision in Terraform, you give it a name, your service account, and then your source content is literally this block here. But Terraform, you got escape the $sign. So the $sign is how we do variables. In Terraform, you have to escape it. So when you copy and paste, if you forget to escape, that is going to break your pipeline. So a bit of a learning curve.
But also one codes, single codes in this project.
Yeah. Don't ask me. This is where I use ChatGPT actually. It's like, go and fix my Terraform.
Transform this to that.
Like, yeah, fix my Terraform because the indentation, I forgot a quote. Sometimes when you interpolate, you put a plus sign or you don't, or like, beyond me.
I feel like it's a perfect use case for LLM. I have Home Assistant at home. I'm not sure like if any of you use like smart home automation. Everything is in, JSON, YAML, and then I'm like, okay, I gave up on all these extra spaces.
Exactly. Yes?
Have you tried to automate the process, so like to validate the YAML file, so you don't have to like copy and paste every time? Have you tried to?
I couldn't find a good extension for my IDE, and this is why I use ChatGPT and like go and that was last year when ChatGPT was not like full on 100% you're probably at work. But yes, I was trying to find like a formatter, something that would tell me and sometimes you run Terraform validate and Terraform plan. Sometimes you get past those, but then when you deploy, because Terraform's like, oh yeah, I got all the field I need, and it's when you deploy that then it goes, I can't parse you, and you'll be like, 70 commits later.
You can also use linting. That's helpful as well sometimes.
I'll come and ask you in
Yeah.
a second. What do I have to
YAML
install?
linter, yeah?
Because I got 70 Terraform extensions, none of them is good.
It's a YAML extension.
Yeah, that didn't work either. Didn't work in that one. It works in if you're just a YAML, but then that one is not a real YAML. That one in Terraform because it's embedded in chaos. But once you get past all this hurdle, you can do lots of things. So you can do try catch, for example. If you do an HTTP call, you can try 3 times and eventually fails and log it. You can do switch, which is the same if statement. This is where it gets messy, you see? Because you go, if this condition is verified, your next step is this one, otherwise this other one. So when you have them on a list, you're not following this, you're going like this.
Are these YAML files? Yeah, that's YAML syntax for
This
try
is-
catch?
This is this bit. It's inside the Terraform, so you can see I go double.
Yeah, it's all YAML.
Inside, inside.
Yeah.
Oh my.
You can do loops, and then
Oops.
it has some
YAMLs.
built-in functionality like base 64 coding and encoding. All the pub sub messages get encoded, so if you're pushing, you gotta encode first. If you're reading, you gotta decode first. And there are like 20 rounds until you find the right shape. So yeah, you can do a lot of things. Do not forget to give permission, because all your steps might require you to talk to other sources, including console log. I think when I try to mine, I have to give permission to be log writer. So you think you get that for free, you don't. And this is the thing that just want to save your life. Google official docs as a cheat sheet for workflow. So it will tell you how to declare your variable, any kind, how to do like condition statement, how to do loops. You can do differently, how to do parallel step. So here, here's where you have to go and save your life, basically. And last thing I was going to quickly touch on. This is step function in AWS. You can enable something called execution logs. Okay, if you're in production, you go PII, do not do that. But if you can, it's very helpful because when you go to the execution logs, it will tell you obviously the flow that be followed, where it failed, but then you can see input and output. So it will tell you what went in and out of each step. So if you're like me, and you do something stupid with your formatting, the data type format is not correct, so your step fail. And here you'll be able to say like, oh yeah, I passed, I don't know, I nested down level in the object, this is why the field doesn't exist. In GCP, there's nothing similar. You can still see execution logs, so see your flow, see which step failed, but it's not gonna tell you anything more. And the logs that you actually have here is what you logged in your workflow. So if you had a try catch or whatever, this error log this, like me, unsupported operal types. This is me not be able to interpolate in Terraform. It will log whatever you tell it to log, but you can't see whatever is happening in between. So it's a bit of a struggle. If you're calling a cloud function, you can use the cloud function logs, obviously, to help you out. But the function, the workflow itself is a bit. That's me. Any more question or suggestion for my YAML?
So say if you started again learning GCP, what would you do different?
I think you kind of have to get out of whatever you knew from other provider. Like don't try, say it's good that you know what services are available and can just get your repair, but don't get bogged down like me, like, oh, I need a policy. It's not good policy.
Yep.
Or like other things, as I was saying, for the cloud function, you know, the HTTP URL is already provided. So you kind of have to be very strict with yourself, like, no, I know that, but I'm gonna put it in the back of my mind and ignore it.
I have mixed, what's the difference between step function and lambda function?
So step function is an orchestration tool. So it's like a flow chart. If I go
It's
back.
only for flows.
It's this. So you're basically saying, let's say I got an event coming in, the first thing I'm gonna do is invoke this lambda function is gonna transform it. And then I need to write a record to Dynamo.
Yeah. Essentially, each step here is a lambda.
I mean, yeah, maybe in lambda I can define all these as well, or not?
Yeah. Yes, you can do both.
Both.
So you could have a gigantic lambda that does all your logic,
Yeah.
but sometimes you use a step function because it gives you more flexibility or better flow management, and you could have more steps here code. But it really depends how you build your Lambda and your step function, whatever is going to be future-proof. For example, here your this was a fraud check on an order. So your Lambda could just go get the order, check if it comes from a dodgy address, and then send it over. It's like 3 steps you need to do in a Lambda. If your logic becomes more complicated, like if your order is over $1,000, do this. If your order has those 3 items, do that. Your Lambda becomes bigger and it becomes more fragile. So when you change the code, it's so complicated that you don't want to break it. So when you have a step function, it's a bit clearer which step you can add and remove.
But also, a typical task for step function is to parallelize some work. So let's say 500 files were uploaded to S3 bucket. You need to process all of them.
But Lambda function can be parallel, I think, as well.
I think Lambda.
But the Lambda has the limitation. It can only execute your function.
15 minutes.
15 minutes.
Well,
If you
it's
have
not even about
the function
15
after 15 minutes.
Yeah, it's not even like 15 minutes because also each
But
Lambda
in
has
parallel? So if I will try
Execute,
to
yeah,
work all
yeah.
files as one Lambda call, let's
Yeah,
say.
whole
Yeah.
function execution, it should be under 15.
There is also only like based on the Lambda size and the memory allocation, you only get in, for example, only 1 CPU. So if you want to have multi-threading or something like that, Lambda is not a good option.
Yeah. In
So
this
you
case, I
use
need
step
to go
function,
to
and you can also throttle. You can
But
say
can Lambda function call another Lambda function?
Yeah,
Yeah,
Yeah.
that's
In that case, I will.
before step functions were introduced, that was the way
We
everyone
deal
was
with-
trying to recreate the same behavior. You have like Lambda function sending messages to the queue, queue
Yes.
invokes another Lambda.
Yes,
But instead of writing out that amount of code, you can do it like this using step functions.
And you
But
can
sometimes
usually
it's like personal preferences.
And rollbacks, right? If you're Lambda invoking other Lambda via queue, any rollbacks would be a nightmare, right? Like if
Yeah.
But my frustration would be if I would be a new developer to understand, okay, where we have this logic. Some part of logic we have in Lambda function, some we have in step function. I
No,
need to
the logic-
guess.
logic is in Lambda functions. Step function is only telling which Lambda functions to
call.
invoke
It's
one
like
after
orchestrating
another.
it.
Yeah. It also depends because there's like native step you can do in the step function directly. So if you want to write to Dynamo, you can do it from a step function. You don't need a Lambda to write to Dynamo, sorry, database. You can do it there. This is like integrated with other AWS services.
Oh, so I can use database values from here.
Yeah, you can post event to event bus. It's the same actually in the workflow. You can just post directly to a PubSub. You just have to give permission, but you don't need to create a cloud function that write your PubSub. So if you need to do a lot of stuff, this is integrated with a lot of services, so you just have a step. So you don't need to provision a Lambda to do your logic, you do it straight from here.
I mean, what I remember when we have created the price list to get the price, for example, for particular, you need to check, is it a special discount that works from that date till that date? That logic and logic can be created even by users, so it's not. There is a huge cycle that performs lots of logic, and it will not fit this step function idea just to get a price, and it will be only Lambda function.
Yeah, it really depends the type of steps you have to do and how complex is your logic. And if you think if you want to add more steps, it's going to be easier to be in a Lambda, or it's going to be easier to have like a flowchart basically. And then this also does all the like retry and wait. So if you're trying to write to Dynamo and Dynamo is busy, you can say wait 2 seconds. You can do like incremental, like wait 2 seconds and then try again and then wait 4 seconds. And if you have to do it in a Lambda, you'll have to write your own retry logic in your Lambda, while you get it for free, basically.
Well, it's using like state machine. So wherever,
Yeah.
like my answer is always, if it's only one state, so you either get price or not get price, then you probably don't need step function. If you have a task that has multiple steps, for example, validate, retrieve, you know, kind of classify, whatever, then each Lambda can update maybe dynamically, because also state machine can run for multiple hours. So you might
Yeah.
see it in one step where, for example, you're waiting for some data to be uploaded to the database, and you're just gonna query maybe every like 10 minutes. And the state
Yeah, and you can do
will-
things about waiting for token to come back as
Yeah.
well. So
Or it
yeah,
could be
you could
like
just
event
send
thing.
the task, and then you wait until there's there's like a waiting step where you wait for the token to come back, this task has been completed, and then you proceed, while your Lambda spins up and then it comes out in 15 minutes and you lost.
So I have a question to you. Comparing to hyperscalers, which one would you use for your new project? If you have a choice between AWS and GCP?
Well, I use AWS because EventBridge is my favorite service, and it's not good enough in GCP.
Are there any good things about GCP?
The color scheme is terrible, right? That's just a giveaway. I mean, it works.
Well, we've got John here, who is also converting from AWS to GCP.
It's
Yes. What is your experience?
let's say I think
pretty much the same.
the best limitation I found was the pub sub. That was a big letdown for me. The workflow syntax, I don't know how many hours I spent in that. So that's I think it's a steep learning curve. And that was last year before all the AI was deeply embedded. So maybe now it's going to take me way less.
And in terms of performance, cost, availability?
I've got no visibility on that.
Okay, cool. Happy developer.
Yeah, exactly. I'm one of the minions, man. I don't know. I can look at all. But I don't know. I think that somebody told me they used to be AWS user, got converted, and I'm like, how did this happen? But yes.
How much does it take, let's say, longest script, Terraform script to establish environment? How long does it take in seconds, minutes?
I don't say minutes.
Longest.
I don't know. I don't think I deploy something that big. Well, it's difficult to say because when you use our pipeline, there's so many checks. They run our pipelines like for like 20 minutes. But if you just run a like Terraform plan and validate, sorry, you go validate, plan, and apply, it's minutes. Like 5 minutes maybe.
If I only work in GCP, like, should I be moving out to AWS or Azure?
I mean, if you like it, I don't see why you wouldn't change.
It seems simpler.
I think if you know more, it's better for you to get a job.
in GCP.
But I don't know, sometimes I feel like, because this is where I started, it's like the imprinting, so you kind of compare everything back. But say, apart from Event Bus, there was something that I just thought about, and was like, oh yeah, like Cognito, we were trying to see, we were building like a AFF layer, so we need clients to come in and be authenticated, and the first thing I think is like, you're going to do a Cognito pool. And then it just Google it, okay, what's the equivalent? It's like, it's not equivalent. And I'm like,
I think there is, I forgot the name, but it's something to do with identity.
there's also like a service-to-service identity thing, but you have to import a library and create a token, say this is my audience, give me a token, and then use that. And I'm like,
and then,
I don't know, it seems complicated.
Right. But you can also use Firebase for something like
Yes.
Incognito, which is...
I have no idea how that works.
Okay. I've recently got into Firebase, which is a product of Google, and...
Yeah, because I think they also use that as the IDP provider, right? To authenticate, like a login.
Oh yeah, anything, Facebook,
Yeah.
Apple, and Google, anything, Microsoft as well. Yeah,
But I feel like it's better to know both.
both, yeah.
Probably even
If you're getting
Azure as
paid
well.
for it, or...
Because it just, you know. So then you're more flexible, and then it gives you more exposure. So you can do the reverse. You'll be like, oh, in GCP works this way. Does AWS have the same? And then you can cherry pick. You had a question.
What are your thoughts on the observability parts? Like comparing GCP and AWS, do you find it more useful, or like what are some pros and cons that you've learned so far?
Funnily enough, in the project I work, we didn't have any alarm, so I do know how those things work. Yeah, no, don't even get me started. But we are consultancy, so I went, we need observability, and then they were like, fine. The logs are the same, for example. It took me a while just to get around the syntax, but then you can, like the Cloud Function logs are like Lambda logs is the same. And I feel like you can do and create alert and alarm, so I'm expecting it to work the same. I mean, otherwise it's bad.
Do you have experience with Azure?
No, haven't got there yet.
Next meetup.
If I do go across, say I work in an agency, so sometimes we have to work with the infrastructure that client has.
Right, yeah.
So sometimes it's our choice. We can recommend what we think is best, and sometimes they already have the environment established, and this is how I end up working with GCP. I'm like, okay, give it a go.
Why does the like Google functions as a Docker file for the runtime?
Say it again, sorry.
So you said like the Google Cloud Functions needs to have a Docker file?
Yes, so
like
if you do a cloud function, you store the code in a bucket, like you zip it, like a Lambda is just your TypeScript file, well, JavaScript file or Python, whatever. If you provision a cloud run, you need a Docker file.
All right.
So there's kind of two different services, but they're kind of the same, because I believe the cloud function, GCP doesn't, like, behind the scene, it makes it a cloud run. So I magically create a Docker file for you. And this is why now they're called cloud run function instead of just cloud function. It's confusing. Yeah, Docker and another learning curve. I'm putting my hand in the sand. Don't worry with that.
Yeah. So with Cloud Function, they typically use Docker to build your project and then deploy it as a function. So that's like the back end of it.
Responsible for managing your runtime. Like they have like in AWS you have like the managed runtimes like Node.js, Python and stuff. But Google you have to manage your runtime.
Not necessarily. Like you can just provide your code, but the way they build it is through Docker.
Use the Docker file to like Docker content to build your source code.
Build the source code and then deploy it.
Cool. Any more questions? Oh, advice for me, because I'm still working with GCP. Now I know better, but let me know if coordinator works, if there's a better way to look at logs.